In this tutorial, we will learn core concepts in audio engineering and how to set up Audacity to apply those concepts in it. By the end of the video, you should know important concepts in audio engineering and have set up Audacity to be able to do audio mastering. But you will also know how to apply those concepts to pretty much all other audio software. Out of the box, Audacity is not fully usable for audio mastering and we need to set it up. In this tutorial, we will learn to install plugins in Audacity and the concepts of what a waveform is, what decibel are, how to check peak level and the RMS of a waveform. In the next parts, we apply these concepts and do actual audio work. So, without further ado, I would say let's do it. Audacity can use several plugin formats to expand its functionality. We will install some free plugins of type Nyquist later. These are simple text files with the ending NY. To install them, open Audacity, go to Tools, then Nyquist Plugin Installer. Click Browse and locate your downloaded plugin. The plugin will appear in the corresponding menu section. When people say waveform, they talk about the actual audio. It is represented by a wave on music software. This is the thingy that looks like a fish skeleton. The waveform is an actual wave. Zoom in and you will see it. The wave is basically the vibration of your speakers over time. It can be seen as the sound wave that reaches your ear. A decibel is the unit of measure for audio loudness. How much is a dB? dB are not absolute units. They always compare in relation to something else, and in different situations the reference is assumed and not always stated, which makes understanding difficult for beginners. For example, the reference point is different in real-world measurements like concerts or noise than in digital audio processing. So when you read, this audio is 90 decibel, what is really meant is, this audio is 90 decibel louder or quieter than the reference point. In the analog world, decibel are compared to the most quiet sound measured, which is referred as silence, but it's not strictly silence. This point is labeled as 0. So a music concert being 90 decibel loud is 90 decibel louder than silence. Meanwhile, in digital audio processing, the point of reference for loudness is set to the maximum level a system can safely output, which is labeled as 0. So all audio loudness values are usually negative because we talk in reference to the maximum of 0. I know this concept of reference points is confusing at first, but it will become clear in a moment. Take a look at this audio samples. One is below reference and the other goes up to the reference point. What is the reference, you might ask? And why is it not optimal that one is not reaching the maximum level? You can imagine the reference as the maximum output whatever system will be later used for playback. If a listener has a small radio, then it might be, for example, 20 watt. If a listener has a big system, then it might be 100 watt. Whatever system it is, if you define your audio to reach only half the possible reference point, then the system will never be able to reach the full intended loudness. I did some lab testing and you might imagine the results. The whole point of mastering is ensuring that your audio will sound optimally on whatever device a listener will use. If you don't optimize, then you might have sad listeners. Let's look at it in Audacity. Let us load a waveform and turn decibel mode on. To the left of the waveform, there is like a vertical ruler that goes from -1 to +1. It is mirrored along the center of each channel, so we usually only look at the upper half. This is by default on linear amplitude level display mode. We need to see decibel, so right-click it and select linear decibel. Even better, open the Audacity Preferences dialog and change the app settings to linear dB mode to make it permanent. Now the scale indicates how loud your sound is in decibel. The range is from 0 to basically infinite, but the usable range is to around 30. As a quick side note, because of the way human brains work, for us to perceive a sound double as loud, the sound wave energy must be 10 times higher. This is described in what science calls the psychoacoustic model. This is important to remember when setting loudness. For a sound to be double as loud, we must increase 10 decibel. Therefore, 60 decibel is twice as loud as 50 decibel. The peak level is the highest amplitude, or volume, that your waveform actually reaches. It's important when trying to avoid clipping and sound distortion. By default, Audacity only shows peak level on the play monitor, but not as a readable value. Knowing the current peak decibel level is needed to see how much you can still raise your volume. Anytime a waveform reaches 0 decibel, clipping or distortion can occur. Audacity has no built-in tool for this, so we need to install a free plugin. I recommend the free Show Amplitude plugin. See the link below. To use it, you open your audio. Then select the audio to be analyzed. In most cases, you can select all audio using the keys Ctrl-A. Then go to the menu Analyze and Amplitude. You need the top decibel value, so you can select any mode as long as that value comes out. The result is given per channel. Normally, we only need the loudest value of both results shown. So in this case, it's 426. We use negative values, and the value closest to 0 is the louder value. Remember, the value 426 is what we saw before, and now you can see it matches what your eye can kind of see on the scale. RMS stands for root mean square level. It is, broadly speaking, the average amplitude of your audio in decibel. It's not the average loudness. This is useful to have a feeling where the core volume of your audio sits. With it you can, for example, more confidently cut unneeded audio peaks. More on this later. In Audacity, you can get the RMS by selecting the whole track and going to Analyze and then Measure RMS. Then note the RMS value you need. In most cases, you will need the stereo value. So, that covers the basics. Let's get to some actual sound work.